We have addition of algebraic fractions, so to add these two algebraic fractions we need to have the same denominator. So first let's try to factorize, because we have 16 and minus y squared, so if I rewrite 16 that this is 4 to second power, we will have here difference of two perfect squares. So let me rewrite this. We have y plus 3 over 4 to second power minus y squared, and the second fraction denominator we have y squared minus 7y plus 12. We have general quadratic trinomial. We can try to factorize this because we have y squared. So first I will put y and y times y give me y squared, and next we have to check if I can find two numbers which I multiply and I will have 12, and when I add them I will have negative 7. So it will be of course negative 4 and negative 3, because negative 4 times negative 3 give me positive 12, and negative 4 plus 3 is negative 7. If you multiply every expression in the first parenthesis by every expression in the second parenthesis and you combine the like terms, you will have exactly the same what we have here at the beginning. So we see that we can factorize this denominator. So now we will use difference of two perfect squares formula to factorize the first denominator. We have like a squared minus b squared versus a minus b times a plus b. A is equal 4 and b is equal y in our example. So numerator we have to copy. We have y plus 3, and now we will have 4 minus y and 4 plus y in the denominator. The second algebraic fraction we will copy. Let's see what now we have in the denominators. We have y plus 4 and y minus 3 we have, and we have y minus 4 and 4 minus y. We can factorize negative sign and we will have y minus 4. So let me do this. If I factorize negative sign from 4 minus y, so it will be negative 4 plus y, because when I multiply by negative 1, negative 4 it will be 4, and negative 1 times y will be negative y. It's the same what I have here. The rest we have to copy. Y plus, of course, y plus 3 over y minus 4 times y minus 3. And now I will take this negative sign to the numerator, because before this whole expression I have negative sign, so it will be y plus 3 over, and now I can put first positive variable minus 4. We have y plus 4, and the second algebraic fraction y plus 3 over y minus 4 times, of course, parenthesis y minus 3. And now let's see what we have in the denominators. We have y minus 4 and y minus 4. So this denominator will have y minus 4 for sure. Next we have y plus, and we don't have y plus 4 in the second denominator, so we will multiply this denominator by y plus 4 to have the same denominator. If I multiply this denominator by y plus 4, I have to do the same with numerator. And now we will have y plus 4 in the denominator, and what else? Y minus 4, y minus 4, y plus 4 and y plus 4 we have, and here we have y minus 3. It means we have to multiply the first denominator by y minus 3. We need to have the same denominator, that's why I multiply this denominator by y minus 3, and when I multiply denominator, I have to multiply numerator by the same expression. So now in denominator we have y minus 4 times y plus 4 times y minus 3. The numerator is the same, so now we have to do multiplication in the numerator. So negative sign I will put first, and I will have to put this now the result of multiplication in parentheses, because I have to change the sign, because before this whole expression we have negative sign. So now y times y is y squared, y times negative 3 is negative 3y, 3 times y is 3y, and 3 times negative 9, 3 is negative 9. And we have plus, the numerator is the same, y minus 4. I can change the order, and first I will put y plus 4, because here in the first denominator I have y plus 4, the second expression, and y minus 3, the last. So now multiplication, y times y is y squared, y times 4 is plus 4y, 3 times y is 3y, and 3 times 4 is 12. So this is equal. Now we see that we have the same denominators, so we copy denominator and we have to add numerators. But now first we have to change the sign. Before this whole parenthesis we have negative sign. And what else we can do? We have negative 3a and positive 3y, so this we can reduce. So now we have negative y squared, and negative give me positive 9, and we have plus y squared plus 4y plus 3y and plus 12. Now denominator we will copy and we can combine the like terms in the numerator. Y squared, negative and positive can reduce, and these are the like terms, and 9 and 12. So we have 9 and 12 give me 21, and 4 and 3 will be 7y. We can factorize 7, because the greatest common factor for 21 and 7 is 7. So we have 7, and in parentheses we will have 3 plus y, and in the denominator what we can do? The denominator we will copy first. Now let's check if we can reduce something. We have here 3 plus y, so it's like y plus 3, and here we have y minus 3, so the sign is different, so we cannot reduce anything. So you can always again use the difference of two perfect squares and combine these two expressions, or you can left like this. This is my solution.